There are objects in the universe so immense and so powerful, they stretch the very limits of imagination. A place where gravity bends reality itself, where time slows, and where light itself is trapped forever. This is not a star or a galaxy, but an infinite darkness wrapped in fire. A black hole so massive and powerful, it dwarfs anything else we have ever found. And its name is TUN 618. It lies near the border of the constellations Canes Venatici and Coma Berenices. When astronomers at the Ternant-Sintla Observatory first recorded it in 1957, TUN 618 appeared to be just another faint blue star. But later spectroscopic studies revealed its true nature. It was not a star at all, but the core of a distant galaxy powered by a black hole of unimaginable scale. TUN 618 lies more than 18 billion light-years away. So far that the light we see today began its journey when the universe was less than a quarter of its present age, at a time when galaxies were still forming, and the first generations of stars lit up the darkness. At such distance, TUN 618 cannot be seen directly. It reveals itself through its glow, because this black hole is not an ordinary one. It is one of the most powerful phenomena in the universe, a quasar. Quasars are the blazing hearts of young galaxies, powered by supermassive black holes consuming colossal amounts of matter. Gas and dust spiral inward, accelerated to nearly the speed of light. This accretion disk surrounding it radiates in every wavelength, from radio waves to visible light to deadly X-rays and gamma rays. Collisions and friction within the disk generate temperatures of tens of thousands of degrees. The result is a beacon so bright it outshines entire galaxies, making it visible across the entire universe. Within this maelstrom, magnetic fields coil and snap, launching colossal relativistic jets of plasma. These streams of plasma blast out from the black hole's poles at nearly the speed of light. Each jet stretches for millions of light-years, longer than entire galaxies. They carry enough energy to shape their host galaxy itself, blowing away gas, halting star formation, and altering the course of galactic evolution. The TUN 618 is one of the most luminous quasars ever discovered. Its energy output equals the combined light of 100 trillion suns. If it were placed at the center of the Milky Way, its bright light would outshine every star in our galaxy. It would be 23 times brighter than a full moon, and it would completely erase our night sky. At the center of this radiance lies the true colossus, a black hole with a mass of 66 billion suns. TUN 618 is more than 16,000 times heavier than Sagittarius A, the black hole at the center of our own galaxy. Its event horizon, the point beyond which nothing can escape, is a sphere of darkness 400 billion kilometers across. Our solar system, from Mercury to Pluto, could vanish within it, with space left over. To stand near it would be to see the laws of physics bend before your eyes. Around the shadow of the event horizon, a glowing halo would form. It would be light being bent back toward the observer, trapped in orbit before finally plunging inward. Time itself would slow. Seconds near the horizon would stretch into years for the wider universe. An observer far away would see anyone close to the black hole frozen in place, trapped at the edge of eternity. At the last stable orbit, the black hole would dominate the sky, a horizon of absolute darkness encircled by fire. As we approached, colors would shift unnaturally. Radiation near the horizon would be gravitationally redshifted, stretched to longer, darker wavelengths. To our eyes, once bright light would fade into deep crimson, as if the black hole was bleeding the color from the universe itself. Further beyond lies only collapse, a singularity where density becomes infinite, and where our current understanding of physics breaks down completely. Supermassive black holes are thought to begin as smaller cores, the remnants of the very first stars, or the direct collapse of massive clouds of primordial gas. Over billions of years, they consume everything around them, swallowing stars, pulling in gas, and fusing with other black holes. But TON 618 pushes these theories to their limit. To have reached 66 billion suns so early in cosmic history, it must have grown at an extraordinary pace. Its scale suggests either an unusually massive origin or feeding conditions in the young universe far more extreme than we once believed. Its very existence challenges our understanding of how black holes evolve. Quasars like TON 618 are not just monsters, they are also windows into the past. Because they shine so brightly, their light travels across billions of years, passing through the gas that fills intergalactic space. By analyzing this light, astronomers can measure the chemistry of the early universe. They can trace the distribution of matter and study how galaxies grew and changed in the first billion years after the Big Bang. TON 618 is both destroyer and guide, illuminating the hidden structures of the universe. And when we look upon it, across 10 billion years of distance, we glimpse both the terror and the wonder of the cosmos. And even now, as you watch this, it continues to feed. Invisible to the naked eye, untouchable, unstoppable. Matter falls inward in a silent scream, spiraling, heating, accelerating, until friction turns it into radiation brighter than galaxies. The disk does not simply glow, it roars in energy. Charged particles collide at relativistic speeds. Magnetic fields twist like cosmic serpents, snapping and reconnecting with explosive force. Each second, more mass than entire stars is converted into pure radiation. And yet, compared to the size of the universe, even this titan is small. Because beyond it lie trillions of galaxies. Beyond those, trillions more. An ocean of structure stretching farther than any mind can truly grasp. And somewhere among them, other giants may exist, larger, older, even more extreme. We have only just begun to look. Every improvement in telescope technology extends our vision deeper into the past. Each new dataset sharpens the outline of cosmic history, and with every observation, the universe becomes both clearer and more mysterious. Dark matter still outweighs everything we can see. Dark energy still drives cosmic expansion. Singularities still defy quantum explanation. The more we learn, the more profound the questions become. So, if you enjoyed this video, hit like, share with friends, and subscribe for more amazing content.